It's time to talk about relationship cardinality. Now, cardinality, by definition, refers to the uniqueness of values in a column. So, for our purposes, all of the relationships that we're going to be creating with the data tables that we have in our model should follow a one-to-many cardinality. One instance of every primary key from our lookups, but potentially many instances of each foreign key from our data tables. So looking at the screenshot here, in this case, we have one instance of each product key in that product lookup table. You'll see that blue box around the number 1, since each row contains attributes of a single product, name, SKU, price, etc. On the data table side of that relationship, because there are many instances of each product key, which is the foreign key here, you'll see that the relationship terminates in an asterisk in that yellow box because there are multiple sales associated with each product ID. Now, the other types of cardinality that we're trying to avoid here are many-to-many or one-to-one. So I thought it would be helpful to put a little case study together for each of those two to show you why we'll be using one-to-many relationships instead. So our first cardinality case study is many-to-many. Now consider these two tables. You've got a product lookup table in green on the left, which has IDs, names, and SKUs. And you've got a data table in blue on the right, which has dates, product IDs, and transactions. So if you were to try to create a relationship between these two tables, you'd get an error message that looks something like this. Power BI is going to tell you you can't create a relationship between those two columns because one of the columns must have unique values. And as you can see above, we've got two instances of product ID number 4 in the lookup table and 3 instances in the data table. So now let's take a minute and step back and really think about this for a second. Even if we had some magical way to force this relationship to stick, it really just doesn't make sense logically. So we know that product number 4 was sold 12 times on January 1st, 9 times on the 2nd, 11 times on the 3rd. But since ID number 4 is associated with multiple product names, how do we know how many of those sales or transactions were for Washington cream soda versus Washington diet cream soda, which for the record sounds like the worst beverage on the planet. That's not relevant here, but you get my point. There's no way to make sense of this data with the tables in this kind of form. Now let's move on to our second cardinality case study, one-to-one. Now compared to many-to-many, this one's not nearly as bad. In fact, you can create one-to-one relationships. They're just a little bit inefficient. So consider these two tables. You've got a product lookup on the left, just like we showed before, but without those duplicate ID number 4 rows. And then almost like a smaller product lookup in orange on the right with product IDs and product prices. So if we were to connect these two based on product ID, we're creating a one-to-one relationship since each ID only appears once in each table. So again, unlike many-to-many, there's nothing illegal about this relationship. It's just kind of an inefficient way to do things. So to eliminate the inefficiency, what you could do here is simply merge those two tables together into a single valid lookup. Now, I know what you're thinking. I've been telling you this whole time never to do merging, it's inefficient, use relationships instead. But trust me, in this scenario, it's legit because we're still respecting the laws of normalization. All of our rows here are unique, and this merged blended table still captures attributes related to the primary key. So it still serves one single purpose. So there's your cardinality crash course. Now let's jump back to Power BI and make sure that our relationships follow a one-to-many cardinality. So back in our relationships view, what we're looking for here is that the lookup table side of each relationship shows a 1 and the data table side shows an asterisk. One instance of the primary key in the lookup table, many instances of the foreign key in the data table. So customer lookup looks good, calendar lookup on order date looks good, calendar lookup on stock date looks good, territories one-to-many, product one-to-many, and then we can follow our way right up the snowflake, one-to-many, one-to-many. So it all checks out. We've got a good set of one-to-many cardinality relationships, so we're in good shape.